Let's take another question. As usual, let me just give my current direction in this way. Alright, so those are our current directions. So we can say that I1 is equals to I2 plus I3. So our first loop, okay, so here this piece is negative, and here is positive, okay, here is positive. So if the loop is going this way, then here will be positive, negative, okay. So here is increasing from negative to positive, is increasing, so our 3 will be positive, so positive 3b, okay. All right, so now here see that it's from positive is going to negative, or it's in the same direction, the current is in the same direction as the loop, so there's a voltage drop, so it will be what, 10 watt I1. Here the current is moving from the positive to the negative, so it's decreasing, or the current, this current is in the same direction as the loop, so there's a decrease in the voltage, or there is a voltage drop, so minus 15 I2 is equals to 0. So this is equation 1, equation 2. So let's take this one as loop 2. So here see that it's increasing, so if this is the loop, then here will be positive, here will be negative, here will be positive, here will be negative. But you see that here is negative going to positive, negative, you see that the loop is going this way, and we are moving, and our current here is coming this way, and we are moving from this negative to this positive. So you can see that the direction of the loop and the direction of this current, they are opposite, because the loop is going this way and the current is coming this way, okay. So they are opposite. Whenever they are opposite, that means that there is an increase in voltage, or because we are moving from the negative to the positive, that means that we are increasing the voltage. We are moving from the negative to the positive, we are increasing the voltage, we are increasing in the voltage. So we will have positive 15, okay, I2. All right, here will be negative because it's positive to negative, so minus 20 I3. Here we are decreasing because we are from positive to negative, or because the loop is in the same direction as the current, it's in the same direction, as this current, and this current is the same current through this one also, okay. The same current is coming here, so it's the same I3, okay. Here is the same I3, okay. So here it will be negative, okay, 50 watt I3. Okay, so now let's solve our equations. So equation 1 into equation 2. So let me ignore this voltage and just write 3. This is equation 4. Please. So here is equals to 0. Please, this place, let me rewrite the equation 3 again. So this and this, it will be 70. It will be 70. It's equals to 0. So this is our equation 3. So in that case, let me just cancel this one and then rewrite it again. Okay, so it will be 15i2 minus 70. Then I'll put the i3 here. All right. So we get so we have I2 to be 0.11 amps. Okay. So now I2 into equation 4. So now I3 is equals to 0.25 amps. Now I2 and I3 into equation 1. So it's 0.025. It's 0.025 amps. Okay, 0.025 amps. This one. I3 is 0.025 amps. So it's 0.025. It's 0.025 amps. Okay, 0.025 amps. This one. I3 is 0.025 amps. Which will be 0. So here is 10 ohms. Here is 20 ohms. Here is 50 ohms. Here is 15 ohms. Here is I1, I2, I3. So this is the circuit that we were supposed to deal with. This is the circuit that we were supposed to deal with. So now let's find the various voltages across the circuits. So the various voltages across the resistors. Okay, so let's see the 10 ohm. So it will be 10 times I1, and I1 was 0.135 amps. So you will have 10 times 0.135 is what? 1.32 amps. Okay, so it's what? The voltage across this one is 1.32 volts. 1.32 volts. Okay, so 1.32 volts. Okay, 1.32 volts. So now 3 minus 1.32 volts. Okay, so what would that give us? Okay, so here that means that 3 minus 1.32 volts will give us 1.68 volts. That means that this place is 1.68 volts. Okay, this place is 1.68 volts. 1.68 volts. Okay, what's the voltage across the 15 ohm resistor? So this 15 ohm. So 15 times, here is I2. So 15 times I2. And we got I2 to be 0.11. 0.11. So 15 times 0.11. 0.11. Okay, so that is going to be 1.65 volts. So here the voltage across this one is 1.65 volts. So you see that this place is 1.65 volts and this place is 1.68 volts. They are approximately what? Equal. They are approximately equal, but because of the decimal points that we used, okay, the decimal places that we used. So that means that if we subtract this 1.65 from this approximate 1. So if we subtract this 1.65 from this 1.68, approximately we're getting 0 volt here. Okay, if here is 0 volt, there's no voltage drop across this place. So that means that here will also be 0 volt. So the sum total of the voltage in this loop is what? 0. That means we are what? We are correct. That means we are correct. So that means we are correct. Okay, so now let's see the voltage across this 20 ohm resistor. Across this 20 ohm resistor. So it will be 20 times I3 because the current passing through it is I3. And I3 was 0.025. So 20 times 0.025. Okay, so that is 0.5. That means that the voltage across this one is 0.5. It's 0.5. So this is 0.5 volts. Okay, so then 1.68 volt minus 0.5 volt. So it will give us 1.18 volt. That means that this place, the voltage is 1.18 volts. Okay, that's the voltage at this point. Okay, it's 1.18 volts. So let's find the voltage across the 50 ohm resistor. So that will be the same I3, the same current I3 which is passing through this 50 ohm resistor. So times, and I3 is 0.025 amps. Okay, which is equals to 1.25 volt. So that means that the voltage drop in this one is 1.25 volt. 1.25 what? 1.25 volts. Okay, so now if you subtract this 1.25 volt from this 1.18, it's approximate because of the decimal places. Okay, so that means that here will be what? About 0 volt, approximately what? 0 volt, and there is no voltage drop here, so here will be 0 volt, here also will be 0 volt. So that means that the sum total of the voltages is what? 0, and we are what? Correct. Okay, thank you so much.